Okay, so this question is saying that we've already got a pre-weighed amount of glucose and we need to make up a solution which is a final concentration of 5 millimolar. And how much water then do we need, or how much solvent do we need to add to this 90 milligrams of pre-weighed glucose in order to make up this solution? Now, glucose is a fairly frivolous example, but there are some situations in the lab where you have, for example, a very toxic chemical, and inside a tiny little vial you have the toxic chemical, and you need to try to add a tiny bit of water into that in order to make up a certain concentration. And you can't touch the chemical because it's toxic, but you need to know how much water to add in, and this is a typical calculation involving that. Okay, so let's start with this 90 milligrams of glucose. So in a beaker, say, we have glucose. We have this white powder, which is glucose, and there are 90 milligrams of this glucose powder sitting inside that. We need to then next add water, but we don't know how much water we need to add. And then the final concentration in here needs to be 5 millimolar. Okay, so this is going to be a bit complex. Let's pry apart the 5 millimolar. Okay, so 5 millimolar is equal to 5 millimoles per liter. Okay, this is equal to 5 micromoles per mil. Now, we don't know what to do with this yet because we need to actually figure out how many moles or how many millimoles of glucose we actually have. Okay, so we have to use a molecular weight, 180. This means that 1 mole of glucose is 180 grams. Or the other way to think about it is, if I'm holding 180 grams of glucose in my hand, I'm holding 1 mole of glucose in my hand. Okay, if I'm holding 360 grams of glucose in my hand, I'm holding 2 moles of glucose in my hand. Okay, so let's keep down converting this. 1 mole is equal to 180 grams, which means 1 millimoles is 180 milligrams. Okay, so again, if I'm holding 180 milligrams in my hand, then I'm holding 1 millimole in my hand. In this beaker already, or in this container, you already have 90 milligrams. Okay, 90 milligrams is equivalent to 0.5 millimoles of glucose. Okay, to get that, divide that side by 2, divide that side by 2 as well. Okay, so in this 90 milligrams that's sitting inside this container, this is equivalent to saying I have 0.5 millimoles. Okay, now 0.5 millimoles, and I know I need to get to a final concentration of 5 millimolar, okay, which is why we come back here to this. We've actually gone a step too far over here, we don't actually need that. Okay, so this is saying that 5 millimoles, if I want my final concentration to be 5 millimolar, okay, in 1 liter there needs to be 5 millimoles of the glucose. Okay, if I have 10 millimoles of the glucose, this means the solution will have to be 2 liters in volume. Okay, but I don't have 10 millimoles of my glucose, I have 0.5 millimoles of my glucose. Okay, so 0.5 millimoles of my glucose in how many liters? Well, to get from 5 down to 0.5, we have to divide by 10. Therefore, to get from 1 down to whatever this is, we also divide by 10. 1 on 10 is 0.1 liters, and this tells us that this final volume here is actually 0.1 liters. So if we have 0.1 liters of water, and in this 0.1 liters of water there are floating around 0.5 millimoles, this is equivalent to saying there are 5, or the concentration of glucose is 5 millimolar. Okay, so this is the volume of water you need to add, assuming that the volume taken up by the glucose powder is indeed negligible.